For 4.5 billion years, the sun has kept a quiet, steady, and beautiful promise. It shines, it warms, and it sustains. But this promise has an expiration date. Deep in the core of our star, hydrogen is slowly running out. As this crucial fuel depletes, the core will collapse under its own weight, heating up to temperatures we can barely calculate. This intense heat will push the outer layers outward, and the sun will swell, turning into a bloated red giant. First, Mercury will be consumed, then Venus. As the star's fiery edge creeps closer to Earth, our oceans will begin to boil. The atmosphere will be blasted into space. The surface of our planet will melt into a global ocean of glowing white-hot magma. Some calculations suggest Earth might be pushed into a wider orbit, escaping direct engulfment. But it won't matter. Whether our planet is physically swallowed by the expanding solar plasma or left behind as a scorched black cinder of molten metal, the Earth we know will be gone. Life will have ended long before, reduced to steam and ash, leaving behind absolutely nothing but a dead rock orbiting a slowly cooling white dwarf. We like to think of our solar system as a permanent clockwork mechanism, with planets safely locked into predictable orbits for eternity. But space is crowded, and everything is moving. Out in the cold darkness of interstellar space, there are actually billions of dark worlds, rogue planets, ejected from their parent stars during the chaotic early days of their formation, drifting aimlessly through the void. Some of these dark worlds are larger than Jupiter. If one of these silent giants were to pass through our inner solar system, it would not need to collide with us to destroy us. Gravity alone would do the work. As the massive intruder neared, its gravitational pull would tug at Earth's stable orbit. It could stretch our circular path into a long, freezing ellipse, throwing our climate into extremes that no biosphere could survive. Or worse, it could slingshot Earth entirely out of the solar system. We would become rogue planets ourselves, cast out into the freezing, absolute zero of interstellar space. The surface oceans would freeze solid in days, the air would liquefy and rain down as nitrogen snow, and Earth would become a silent tomb, drifting completely forever in the dark.
Just 66 million years ago, a rock the size of a city struck the Yucatan Peninsula, and in the reign of the dinosaurs. That was a warning. The asteroid belt and the Copper Belt are filled with rocky remnants of the early solar system, and sometimes those remnants slip. If an asteroid 10 times larger than the one that killed the dinosaurs were to cross our path, the end would be swift. The impact would punch a hole straight through our atmosphere, hitting the crust with the force of billions of atomic bombs. The shockwave would flatten entire continents in minutes. Billions of tons of vaporized rock, dust, and soot would be thrown into the upper atmosphere, completely blotting out the sun for years. This is not just a dark night, it is a nuclear winter. Without sunlight, photosynthesis stops. Plants die, followed by the herbivores and then the carnivores. The entire global food chain collapses entirely. Acid rain, born from the sulfur thrown into the air, would turn the oceans into dead zones of toxic acid. The physical planet would remain, but the vibrant, living world we know would be permanently crushed into a barren, silent, and lifeless wasteland.
Deep beneath our feet, a giant liquid iron core is constantly spinning, acting as a giant dynamo. This movement creates a massive invisible shield around our planet, the magnetosphere. This shield is the only thing standing between us and the deadly radiation of the sun. But magnetic fields aren't permanent. Earth's magnetic poles have flipped hundreds of times in the past, and during these transitions, the shield weakens significantly. If the core's dynamo were to stall completely, our shield would vanish. This solar wind, which is a relentless stream of high-energy charged particles, would hit our upper atmosphere directly. Over millions of years, this wind would strip away our atmosphere, molecule by molecule, just as it did to Mars billions of years ago. Without atmospheric pressure, our liquid water would evaporate into space.
Cosmic rays would rain down on the surface, mutating and destroying any cells trying to survive, and nothing could stop it. The planet would be sterilized, turned into a dry, radiation-baked desert, unable to hold on to the air or water needed to support even the simplest bacterial life. A naked rock exposed to the absolute, unforgiving harshness of the deep, dark, and cosmic void.
Somewhere in our galactic neighborhood, a massive star is reaching the end of its life. When it collapses, it may not just explode, it could produce a gamma ray burst. These are the most powerful explosions in the universe, releasing more energy in a few seconds than our sun will emit in its entire 10 billion year lifetime. If a gamma ray burst occurred within a few thousand light years of Earth and its beam was pointed directly at us, we would have no warning. The light would arrive at the speed of light. The side of the Earth facing the burst would be blasted with intense radiation, but the real destruction would happen in the atmosphere. The gamma rays would tear apart nitrogen and oxygen molecules, creating massive amounts of nitrogen dioxide. This toxic brown gas would block out the sun, triggering global cooling. More importantly, it would instantly destroy the ozone layer. Without ozone, the sun's raw ultraviolet radiation would reach the surface. Plankton in the oceans would die instantly, collapsing the marine food web. Land animals would suffer blindness and fatal radiation burns, and the other side would only buy a few hours of survival. It is a silent, instant execution from across the cosmos. Black holes are not just science fiction, they are a stark reality of our galaxy. Most of these objects are born from dying stars, leaving behind a point of infinite density, where the pull of gravity is so strong that not even light can escape. Because they emit no light, they are nearly impossible to see unless they are actively feeding on gas or stars. If a stellar mass black hole were to drift silently into our solar system, we would only notice its presence by the warping of starlight behind it and the chaotic disruption of outer planetary orbits. As it drew closer, its immense gravity would begin to tear the solar system apart. It would pull the gas giants out of their paths, sending them hurtling into deep space or crashing into each other. If Earth were pulled toward the event horizon, the tidal forces would become extreme. Because gravity pulls harder on things that are closer, the side of the Earth facing the black hole would be pulled infinitely harder than the side facing away. The planet would be stretched, cracked, and pulled apart like taffy, a process physicists call spaghettification, before being swallowed forever into the dense singularity. Our sister planet Venus is a cautionary tale. It's a world of crushing atmospheric pressure and choking sulfuric acid clouds, hot enough to melt lead. But billions of years ago in the deep past, Venus may have had oceans of liquid water and a temperate climate much like Earth. Its downfall was a runaway greenhouse effect. Earth is balanced on a delicate tightrope. If our carbon dioxide levels rise too high, or if the sun's natural brightening pushes us past a critical threshold, the unstoppable and catastrophic warming loop will become reality. As the temperature rises, more water vapor, which is itself a potent greenhouse gas, will evaporate into the air. This traps more heat, slowly evaporating more water in a feedback loop that cannot be broken. Eventually, all the oceans will boil away completely, filling the atmosphere with a thick blanket of steam. Solar ultraviolet radiation will split the water molecules into hydrogen and oxygen, and the light hydrogen will slowly escape into space, locking the water away forever. Earth would eventually become a carbon dioxide-choked hellscape, a sister to Venus, permanently sterilized and scorched graveyard where life as we currently know it can never return again. While we worry about asteroids and dying stars, the ultimate threat might come from the fabric of space itself. We know the universe is expanding at an incredible rate, and that this expansion is accelerating, driven by a dark and mysterious force we call dark energy. energy. If the strength of dark energy continues to grow, it could lead to a cosmological scenario known as the Big Rip. In this ending, the acceleration of space becomes so violent that gravity can no longer hold galaxies together. First, massive clusters of galaxies would drift apart. Then, stars and planets would be ripped away from their solar system. As the end neared, the Earth itself would feel the strain. The gravitational pull keeping our planet together would be overcome by the stretching of space. The crust would rip open, the mantle would shatter, and the planet would be torn apart down to its very fundamental atoms. Finally, molecules, atoms, and even subatomic particles would be ripped to shreds by the relentless, unforgiving expansion. The universe would end not with a whimper, but with the literal, violent, and absolute tearing of physical reality, leaving behind absolutely nothing but a cold, silent, and empty void. At the smallest scales of reality, physics tells us that our universe might be built on a fragile lie. This is the theory of vacuum decay. Quantum field theory suggests that the vacuum of space we occupy might not be in its lowest possible energy state, but rather in a temporary, unstable state called a false vacuum. If this is true, a quantum event could trigger a sudden, catastrophic transition to a true vacuum state at any moment, anywhere in the cosmos. This transition would begin as a bubble of true vacuum, expanding outward in all directions at the speed of light. Inside this bubble, the laws of physics themselves would be fundamentally rewritten. The strength of forces would change, and the particles that make up chemistry, atoms, and life would instantly dissolve, unable to exist in the new physics. Because the bubble expands at the speed of light, we would never see it coming. There would be no warning, no panic, and no physical pain. One moment, our planet would be spinning quietly in space, and the next, it would simply cease to exist, erased from the universe as if it had never been there in the first place.